check this out, isn't it interesting? These are leaf-coated ants. They go probably far away, try to look for some food source, and they carry all the leaves.
They're very, very elaborate farmers. And what they do is they put these leaves into the nest where they have a particular fungus that grows and lives off of these leaves. They then feed that fungus to the larvae and to some of the other ants.
And they build a big nest with as many as 7 million ants. It could be up to 50 meters wide and 5 meters deep.
And one day they make a new queen, and she will tuck some of that fungus into her mouth and travel out into the forest until she finds a new place to start this whole process over once again.
Well, that's the first step in any scientific investigation. You're curious about something, so you ask a question. So what's the question?
Yeah, ants are very interesting, but what exactly about ants is interesting?
See, that's the thing. Each individual ant doesn't really know what they're doing. They're just following a little scent trail, and as it turns out, as they're walking across the path, every so often, the ant puts its little butt down and lays down a little bit more of the pheromone, which successive ants going down that path then follow.
Naturally, there are some events that happen and block their path. But how long it will take for the ants to follow each other again, to find their path?
So we have some ideas for our hypothesis. What I'm still interested in is what is it we will actually measure?
So, how long does it take the ants that are carrying the leaves to cross the path?
How long does it take for the ants that are not carrying leaves to cross the path? Do they go over where the original path was?
Around the path. What do they do?
There's all these different variables. We're not exactly sure which ones we're going to be able to quantify.
Okay, that's the thing about science. You never know what will happen till you test it.
Seems like we've narrowed in to focus on this disruption on the trail. We're going to go out and do a pilot study and look at a few things.
Hey, why do we do a pilot study?
We do a pilot study so we know what variables we need to work on. We need to know specifically our method, and we have exactly what we're going to do once we get out into the field.
And these are the pheromones they are leaving behind.
Yes.
Okay. So if there is a natural disturbance, this area would be without pheromones. So it would be like, what to do? Should I climb it? No. Distance also of the cleaning area, because if it's just a short line, they will be probably just avoiding that because it's not that much. But if it's a big area, it will cause more density.
Now that we've figured out what we're going to test, actually setting up the procedure and determining what each person's going to do is where the real teamwork begins.
Alright, so this is the process. I'm taking a still photo every 15 seconds, which we're then going to stitch together and make sort of an elapsed time sequence. We're videotaping the whole experience, and they're measuring how many ants pass a given point each minute. And the premise here is that what we're really looking at is the recovery time.
We get a spike in the data here after the barricade has been released, and then it goes back down to the original rate.
Awesome. I can't wait to graph this. It's going to look awesome.
Graphing is cool. Graphing is cool.
We have done our experiment and we have data, but what we'll do with this information?
So let's take a look at our data here, Katie. We have the data from 3 trials graphed faster recovery with the scrape than with the pod disturbance. The data from trial C seems to show that they recovered about the same time. When we take that all together and average it, we find that although a trend is suggested where the scrape recovers faster than the pod, when you put the averages and the error bars in, there's actually an overlap, meaning there's no statistically significant difference between the two treatments.
Great. Okay. Let's look a little bit at the qualitative data that we collected. The first thing that I noticed was the response of the ants. As soon as there was a disturbance, there was a quick response within seconds. The majority of the leaf-carrying ants started to bunch up, kind of like a traffic jam, all at once. The ants that were continuing across the path, there were a few, but they were few and far between. And lastly, the non-leaf carrying ants started just investigating around the path, and they were trying to figure out, they appeared to be trying to figure out where to go and what to do.
So our hypothesis was that ants would overcome a natural disturbance such as a seed pod on their trail more quickly than an unnatural disturbance such as a scraped area of the trail. What we actually found was the opposite, although our results weren't statistically significant. But that's okay, that's science.
One thing that I thought was really fun was working with these different personalities. I mean, we all had our strengths and weaknesses.
Well, Katie and I, we learned to work together really well through this experience.
It was really fun to go through the scientific process, not just in my own mind, but actually sharing information this time around, which is exactly what this experience is about.
It feels good when you finish something and when you know that you did it well.